Hello. Today we're going to be using the Crazy Fly, the Crazy Radio, and just going through part one, or part zero and part one of the lab. Just how to use the software. We're going to just make sure we know how to map this guy to the VM. Try and flash this with the lab part one software. And then we're just going to try setting some parameters and making sure everything seems to work. So the first step is to boot up the VM. Keep in mind the lab VM should be immutable, which means that whenever you power it off, you lose your work. So make sure, however you want to do it, using Git, using Google Drive, using a shared folder, that you just save your work off of this VM into somewhere else so that when it turns off and turns back on, you still have all your work saved. This is on my computer, so it's not immutable, so you may see some things that are saved. But regardless, let's plug in the Crazy Radio. And first things first, we'll boot this guy up. I usually make sure my mouse is captured. Not sure what happens if you don't do that. Okay, so now the VM is all booted up. And so the first thing we're going to want to do is go into lab part one, and then go into Crazy Fly software, Crazy Fly firmware, and then we want to go into tools, I think. It is tools, right? Yes, because then we want make, and then the instructions say to make this config.make file, and to copy in this instruction and change this value to be valid for your radio channel. The radio channels of all the drones should be mapped using the Excel sheet that we provided. Let me pull it up here real quick. So they should be mapped like this. So if your drone, mine says 1, it should be at radio channel 0, and it is. And so that is why this is 0. So you will need to change that to whatever corresponds accordingly. And then you'll want to come out of here. And in this folder, I think we open a terminal here and we call make cload. Of course, it'd probably be helpful if the drone was on. And whenever you're starting up the drone, just keep in mind that you want it to be on a level surface. And the light should be beating like that. You may realize that you're running into issues if the light ever stops blinking at that same frequency. So like, let's say for instance, I'm starting it up and I'm moving it around. You'll see it beating at a much slower heartbeat. Like that. That means that there is some issue. And usually it's just because it wasn't perfectly level whenever you were starting it up. So if I boot this guy up, now what should happen is I call make cload, and it works. All right, so we're encountering this issue. If you encounter this issue, basically you need to put the Crazy Fly into bootloader mode. So what that means is you can use the power button right here, turn it off, and then just hold the power button on until that blue light blinks like that. Now we're in bootloader mode, and we can call make cload again. Oh, okay. The other problem here is that I have not actually connected my Crazy Fly dongle. So first thing you're gonna want to do is go into settings. Let me get rid of all these and map the USB dongle Crazy Fly. If it isn't showing up as Crazy Radio, it either means that it's plugged into a wrong USB port. So for the lab computers, you usually want to plug it into the actual computer itself and not the USB hub. And sometimes you might just want to unplug it and plug it back in if it shows up as like an unknown device. But if it shows up as Crazy Radio, that means everything is usually good. And so then we come in here and click Crazy Radio. Also, if you aren't seeing this devices, all you have to do is hit Control F, and that will maximize the screen on your screen. And then hit Control F again, and then it'll bring it back, and this whole tab at the top will show up. So that's useful. And you don't want to hit the left Control F. You want to hit the control on the right side of the keyboard. So now let's try this one more time. And it started to flash. So there's another light on my Crazy Fly that's going off right now. And that kind of lets you know that things are being written to the memory of it. So we'll fast forward through this part, and I'll see you whenever we're done being flashed. Okay, so now we're done being flashed. The Crazy Fly just restarted. And now what we can do is we can do Crazy Cart and then the radio number. So for us, it's 0. And yeah, it should begin starting up. If the GUI pops up in the middle of the startup like this, it usually means something is broken. We'll give this a chance anyway. But worst case scenario here is you just Control C in the terminal to terminate it and then just start it up again. If you encounter any issues with the GUI, that's usually the solution as well. All right, so now we should be able to connect to the back end, and it just crashed. So we're just going to restart. Okay, so now we're here. This is the main GUI. First thing we want to do is connect to the back end. And the second thing we want to do is make sure that we're actually connected to the drone. So I'm going to just put a really small amount of thrust on the motors. And if everything is working, we should be able to hit apply and they start turning. And so everything seems to be working. We can also check some logging. Maybe look at roll. We'll log that, see what happens. So this is what it claims the roll is. So I'll give it a little more roll and then a little less. And so you can see there's a little lag in what the logger is displaying, but it seems overall to be pretty good. And we'll stop that for now. So now we have seen how to log things, how to get thrust to go. And you can do a lot more adjustment with logging blocks as well. So you can actually open up this logging block setup file. And this is where we configure anything that we want to log. So we get 3 options that we added here of the state estimate, roll, pitch, and yaw. And that returns the angle of those values in degrees. And then we can also get their rates in degrees per second by looking at these parameters. We can look at the rate set points by looking at these parameters. And we can look at the angle set points by looking at those. There's also a few other useful outputs here that are just commented out. You don't want to have way too many of these logging blocks enabled at one time. Otherwise, you can kind of start killing the bandwidth on the Crazy Fly, and you'll run into issues there. But yeah, these are the ones that you're going to need for most stuff. So we can exit out of that. And then in this parameters. So the first step in the actual part 1 of the lab is to start tuning the yaw rate controller. So in order to do that, we can take our test stand, and you can do this either using the rate output on the test stand, or you can also just use the state estimate of what it says the rate is. Honestly, I usually just use the state estimate over the test stand because it seems to be pretty close. But if you want to get an absolute number, the test stand's also a pretty good way to go. And so then what we can do to edit the yaw rate KP and KI and KD values is we can open up this JSON file here, and you'll see that I already have a yaw KP of 2000. So what you're going to be doing through part 1 of the lab is basically finding values for all of these. And you usually, at least for most of these, are not going to need an I value. You can use an I value. It won't break it, but you don't strictly need one to get a controller that works. So that might be a good way to narrow down your search as well. But we can exit out of here, and then we can set the parameters from the JSON file. So the thing to know with this is that this program is not broken right now. It takes 12 seconds to set the parameters from the JSON file, which is a little lengthy. But when it is done, it will highlight that complete, which means it is done now. And then whenever you open up the file to edit it again, it will just gray it out. So if you ever hit set param twice in a row, you may get confused because it doesn't gray out. And then we can check that we set this correctly by opening up the Git group and looking at SPID rate, and then yaw KP git param, and make sure you hit the button in the right place. 2000. So that means that is right. So then we can come over here, and we can look at the R yaw, which should be the returned rate. And then we can look at yaw rate, which should be the set point. So we'll start logging those. And we will begin setting a yaw rate. And I'm a little confused as to why the logging doesn't seem to be returning anything right now. But we'll try starting it again. Okay, so just restarting the GUI fixed the logging. So now we will set a little thrust, give a rate, and we'll say 10. We'll apply. We should see our set point jump, and we can also see the rate that's following it. So one of the things to keep in mind here is that you don't need your rate to be perfect. You just need it to be pretty good, because then you can tune the attitudes a little bit more tightly. And yeah, that's about it. You just need to repeat this now for all the other axes, and then do an attitude controller as well, which is the same exact idea. You're going to want to change the order of magnitude of the KPs pretty consistently. Around 2000 is the most I've seen needing to do, but you might want to go an order of magnitude lower than that for some of the controllers. So that's all the hints you get for part 1. But thank you and good luck.